In section 2.5, we look at linear functions. A linear function is a function of the form f of x equals ax plus b. One thing to notice in particular is that when you have a linear function, the power of x is equal to 1. So any function that has a higher power of x, or a radical, or an x in the denominator of a fraction, is not a linear function. Now, the graph of a linear function is a line, and the slope of that line is a, which is the coefficient of x, and the y-intercept is the number b. And keep in mind that the slope has a formula, and that formula can be expressed like this, and this is the same as the average rate of change like we talked about earlier. So to briefly summarize, a linear function f of x equals ax plus b has a slope and a rate of change, which are both equal to a, and that number a is a constant, and it's the coefficient of x. Let's take a look at how to graph a linear function. Suppose you're asked to graph the linear function f of x equals 2/3 x plus 4. So we want to notice that the slope of this line is equal to 2/3, and the y-intercept of this line is equal to 4. But remember, the y-intercept is really a point that can be expressed as 0, 4. So we have a couple of different ways of graphing this. Probably the easiest way to graph a line would be to first go to the y-intercept, which is at the point 0, 4, which is right here. And then remember that the slope is the same as the rise over the run. So it gives you literal directions on how to get from one point to another. So what we can do is we can start at the y-intercept, and from there we can rise up 2 and run to the right 3. And when you do that, you get a second point on the line. Now, as soon as we have 2 points on the line, we can sketch the graph of the line. So this is one method for graphing a line. Another method that we could use, which is a little bit more time consuming, is you can get some points. Now, the way to do this is to just pick a couple of x values to plug into the function. So for example, I might pick x equals 0. 0 is always nice. If I plug in x equals 0, we get f of 0 is 2/3 times 0, which is 0, plus 4, which is equal to 4. And then I need to pick another value of x. Now, I could pick x equals 1 or 2, but actually what I want to choose is x equals 3. Now, the reason I'm picking 3 is because when you plug the number 3 into the function, you get 2/3 multiplied by 3 plus 4. And what's nice about this is the denominator 3 cancels with this number 3 here, and you end up just getting 2 plus 4, which is 6. And now I have 2 points on the curve. One point is 0, 4, which is this point right here, and the other point is 3, 6, which is this point right here. So you can either use points to graph a line, or you can just use the slope and the y-intercept. Next, we look at an application of linear functions. So in this problem, it says that a dam is built on a river to create a reservoir. The water level f of t in the reservoir at time t is given by the linear function f of t equals 4.5 times t plus 28, where t is the number of years since the dam was constructed, and f of t is measured in feet. So for this problem, they first want us to sketch a graph of the linear function, and then they ask what is the slope of that graph, and then part C, at what rate is the water level in the reservoir changing? So first, let's take a look at how to sketch the graph. Now, as I just mentioned, we have a couple of different ways of sketching that graph. We could use just the slope and the y-intercept, but the slope here is 4.5, and that can be sometimes a little bit more challenging to interpret in terms of graphing. So what I'm going to do here is just pick a couple of points. So I'm going to pick a t value, and that's going to give me an f of t value. And I always like to start by choosing t equals 0. If you plug in 0 here for t, you get 4.5 times 0, which is 0, and then plus 28 is 28. So that gives us the point 0, 28, which is right here. And then I need to pick a second value of t. Now I can pick any value of t that I want, but I'm going to choose something easy. I'm going to pick t equals 4. So now when I do f of 4, that's going to be 4.5 times 4 plus 28. 4.5 times 4 is 18 plus 28, and 18 plus 28 is 46. So we have the point 4, 46, which is this point right here. And now I can connect these points to get a line. Now when I do this, notice that I'm not going to extend my line to the left of the y-axis here. And that's because 0 represents when the dam was built. So it doesn't make any sense to have a line to the left of that because there is no dam at that particular moment in time. So that's part A. Part B, what is the slope of the graph? Well, the slope is the coefficient of the independent variable, which in this case is 4.5, as we mentioned. And part C says, at what rate is the water level in the reservoir changing? Well, the rate of change for a linear function is the slope. So the rate of change is 4.5, and then we should give some units here. So it says that the water level is measured in feet and time is measured in years. So this 4.5 is going to be given as feet per year. And what that means is that every year that goes by, the water level rises 4.5 feet. For our final example, we have the following. Water is being pumped into a swimming pool at a rate of 5 gallons per minute. So that 5 gallons per minute is our rate of change. Initially, the pool contains 200 gallons of water. The 200 gallons of water is our y-intercept, so to speak. And that's because it says initially the pool contains that much water. Initially means when time equals 0. So what we want to do here is find a linear function v that models the volume of water in the pool at time t. So our equation is going to be v equals a times t plus b. Okay, so this is part A here. And we know that a, the slope of the line, must be equal to the rate of change, which is 5 gallons per minute. And we know that b has to be the so-called y-intercept, which is also the same as the initial value. So it's the value of v when t equals 0. And we know that in this particular case, it's 200 gallons because it tells us that initially the pool contains 200 gallons. So the volume of this pool is going to be 5t plus 200. And this will give us the volume at any particular time t. And keep in mind that t is time in minutes, and v is volume in gallons. Now let's take a look at part B. In part B, it says, if the pool has a capacity of 600 gallons, how long does it take to completely fill the pool? So what they're basically asking us is, when will the volume of the pool equal 600 gallons? So all we have to do is use our formula, V equals 5T plus 200, and we're just going to take the value 600 and substitute it in for V. And when we do that, we get 600 equals 5T plus 200. And then we're going to solve for T by subtracting 200 from both sides. This gives us 400 equals 5T. And then we can simply divide both sides by 5. And that gives us 80 is equal to T. So that means that it will take 80 minutes for the volume of the pool to reach 600 gallons.